Hello and welcome to Math Matters. I'm Ms. Granados and today we're going to talk about creating lists and charts as our sample space. By the end of today's lesson, you should be able to create a list and a chart of all the possible outcomes of an event. You will also be able to use specific words to describe the probability of the event. You will need some paper and something to write with. Go ahead and gather your materials and then come right back. Take a look at this picture. Which one doesn't belong? Select one of the four pictures and explain your reasoning of why that picture doesn't belong to someone or write it down on your paper. Can you think of why another picture doesn't belong? Maybe you can think of why each of the pictures doesn't belong. I'll give you some more time to think about it. Here are some ideas that I thought of. The nickel doesn't belong because it's the only space that has exactly one coin. The 4 pennies don't belong because they're the only coins that are facing the right side. Plus, they're the only ones that are brown, not silver. The dimes don't belong because they're the only coins showing the tail side up. And the quarters don't belong because they're the only coins that add up to $1. What other reasons did you come up with? So now let's move on to the lesson. If you toss a coin, how could it land? There are really only two possible outcomes. Either it will land with the head side facing up, or it will land with the tail side facing up. This is called our sample space. It lists the only possible outcomes of tossing one coin. What is the likelihood that it will land on heads? Well, since there are exactly two possible outcomes, heads is one of the two and tails is one of the two, then it is equally likely that it will land on heads as tails. What's the sample space of tossing two coins? Write on your paper a list of all the possible outcomes of tossing two coins. All right, does your list have these outcomes? Head, head, tail, tail, head, tail, and tail, head. What is the likelihood of the coins both landing on heads? Well, two coins landing on heads is only one possible outcome out of 4 total possibilities. That means there are 3 other outcomes that are possible. Therefore, it is unlikely that both coins will land on heads. What is the likelihood of the coins both landing on tails? Yeah, it's the same likelihood as what we just said for heads. The same likelihood is true for both coins landing on tails because there's only one outcome that shows two tails and three outcomes that show something different. What's the likelihood of one coin landing on tails and one coin landing on heads? Well, there are two possible outcomes that show one head and one tail. But then there are also two possible outcomes that do not show one head and one tail. Therefore, the likelihood of the coins landing on one head and one tail is equally likely as them not landing on that outcome. So now let's switch from tossing coins to rolling dice. This time we're going to throw only one die. We say dice only if there are two or more. Create a sample space of all the possible outcomes of tossing a regular six-sided die. All right, there are exactly 6 possible outcomes. You should have created a list with these numbers: 1, 2, 3, 4, 5, and 6. If you roll the die once, what is the likelihood that you will roll a 3? Well, so let's think about this. How many times does the number 3 appear in our list of outcomes? Just one time. How many other possible outcomes are there besides a 3? Yeah, there are 5 other numbers that you could roll. So it is unlikely that you will roll a 3 if you roll the die one time. In fact, it is unlikely for you to roll any of these numbers if you roll the die one time because each number appears exactly once, and there are always 5 other numbers that you could roll. In other words, it is more likely that you do not roll a 3 than you actually do. Now, what if I ask you this question? What is the likelihood of rolling an odd number? What are the odd numbers listed here? That's right, 1, 3, and 5. So there are 3 possible odd numbers that you could roll. What are the numbers that are not odd? Yeah, 2, 4, and 6 are even. They are not odd. So there are 3 possible numbers that you could roll that are not odd. And the likelihood of rolling an odd number is equally likely as rolling an even number. Now, what if I asked you this question? What is the likelihood of rolling a number less than 7? Well, what outcomes are less than 7? That's right, all the outcomes are less than 7 because 1, 2, 3, 4, 5, and 6 are all less than 7. So the likelihood of rolling a number less than 7 is certain. There are 0 outcomes that are greater than 7. Now let's put the two things together. What are all the possible outcomes of tossing one coin and rolling one die? Well, here it is in a table. There are 2 possible outcomes for tossing a coin, either heads or tails, and then there are 6 possible outcomes for rolling a die, all the numbers 1 through 6. If we take that table and create a list of all the possible outcomes, it would look like this. We can start with the coin landing on heads. If the coin landed on heads and we rolled a 1, that would be one possibility. If the coin landed on heads and we rolled a 2, that would be another possible outcome. And we can continue the list with all the other numbers on the die, rolling a 3, 4, 5, or 6. Then we can create the same list of outcomes, but with tails, if the coin had landed on tails instead of heads. The numbers would all still be the same outcomes, only the coin would change on that side of the list. So how many total outcomes are there? That's right, 12. 6 outcomes with heads and 6 outcomes with tails. Now, what is the likelihood that we toss heads? Well, if we look at our sample space, or list of possible outcomes, we can count all the possible outcomes where heads is tossed. There are 6 possible outcomes that include heads. How many possible outcomes do not include heads? Well, there are also 6 possible outcomes that do not include heads. Therefore, it is equally likely to toss heads than to not toss heads when tossing one coin and one die. What is the likelihood that we toss heads and roll an even number? So now we need to look only at the heads column and then pick the numbers that are odd. What numbers are odd? 1, 3, and 5. So there are 3 possible outcomes that include heads and an odd number. How many possible outcomes do not include heads and an odd number? Well, there are 3 possible outcomes that are heads but do not include an odd number, and there are 6 outcomes that do not include heads at all. So there are more outcomes that do not meet this criteria than outcomes that do. Therefore, the likelihood of tossing heads and rolling an odd number is unlikely. Now it's your turn to write out our sample space. If you had to spin this spinner once and roll a regular 6-sided die, list all the possible outcomes. I'll give you a couple minutes to write your list down. All right, you ready to see how you did? Here's the table. The only possible outcomes for the spinner are red, blue, and yellow. The only possible outcomes for the die are the numbers 1, 2, 3, 4, 5, and 6. Here's the list. It's best to start with one color and then list all the outcomes for the die, and then continue with the next color and continue with the die, and then the last color. It's important when creating a sample space to be organized, to make sure you include all the possibilities without duplicating or writing them down twice, any of them, and also to make sure you don't miss any of them. All right, so these were the learning targets for today's lesson. How do you feel about your ability to create a list and a table of all the possible outcomes of an event? How do you feel about using specific words to describe the probability of the event? This week, we will continue learning about probability, so make sure to come back tomorrow. For Math Matters, I'm Ms. Granados. Have a mathematical day and keep on counting.